So you've decided you want to make some money with your web application. You have your idea, you have your plan of action, but you don't know how to start charging for your indie product. Well, in this video, we're going to look at how you can implement the two most important features of any web product: user authentication and payments. We'll be using Clerk to store our users and manage authentication, as well as Stripe to manage payments for subscriptions or one-time purchases. This will all be done within a NextJS tRPC codebase in a way so that you can extend it for your own web products. The first part of this video will be focused on the architecture, just so you get a deep understanding of how the services we use will integrate with our application. From that point on, we will use it as a reference to guide us through development. But before we continue, if you are looking for a software engineering role in order for you to bootstrap that product of yours, you can visit webdevjobs.io to find the perfect position that suits your skill set. We also have a newsletter which you can sign up to, where we will send open positions on a weekly basis. Best of luck. High-level view of our architecture will consist of our application, which contains both the client and the server. This will then communicate with Clerk and Stripe via API calls and webhooks. So to start with, what does our authentication process look like? Well, first of all, the user will be presented with a sign up and login button. Focus here is mainly on sign up, as login will be taken care of by Clerk. When the user clicks on the sign up button, they will be sent to a Clerk form where they can either sign up with an email or via Google, or whatever authentication method you decide. Once the user has added in their credentials, two things will happen on Clerk's end. First of all, the user will be stored within their database, which is nice because we won't need to store user information such as passwords and sessions. The second thing that will happen is that Clerk will fire off a webhook event. The event we are concerned with is user.created. Clerk fires this whenever a new user has been created and added to their database. Our server will be listening for this event, and when it receives one, we'll create an account for that user within our own database. Now you may be asking, why do we need to create an account when we already have the user that Clerk stores? Well, for our case, Clerk only takes care of user credentials and authentication. We also want to associate each user with a subscription or payment that they have made. So our account will be like a middleman between Clerk and Stripe. So for that, we will have a one-to-one relationship between a user and an account, where one user will have one account. Our account table will have the following schema: the ID, which will be a string, the user ID, which will be the ID of the user sent back from Clerk, created at and updated at to keep track of when the account was created and last updated, the Stripe customer ID, which will either be a string or a null value. This will hold the customer's reference ID for Stripe so that we can track their subscription for reasons when they might cancel their membership. The next column will be the package, which will either be monthly subscription, lifetime, or null. And then a column which will indicate the overall status of the accounts, whether they are inactive, active, or they have cancelled their subscription. So now that we've brought Stripe into the conversation, how will the flow look for that? When a user has first signed up, they'll be brought to a page where they can choose if they want a monthly subscription or if they want to pay a one-time fee of a lifetime package. However, when this page initially loads, the client will make two requests to our server. One request will be for the checkout link for a monthly subscription, and the other will be a link for the lifetime package. When the server receives those requests, it will then ask Stripe to generate the links, which the server will then send back to the client. So when the user clicks on one of the buttons, they will be sent to the correct checkout page. For example, if they click on the button for the monthly subscription, they will be redirected to the form for that payment process. Now we can create our own checkout forms, however Stripe's forms are pretty well laid out and gets the job done. Once the user gets onto the form, they can enter their card details and then click submit. When a user clicks submit, Stripe will save the credit card information on its end, as we cannot be allowed to store credit card details on our own database. At the same time, Stripe will fire a number of webhook events. The two that we are concerned with are customer subscription created, which relates to an event where a subscription has been created. This will only fire if a user has opted in for a monthly package. The second webhook is checkout session completed, which relates to the lifetime package. Our server will be listening out for these two events, and then based on the events it receives, it will make the necessary changes to the user's account within our database. For example, if the user has selected the monthly subscription, then we will update the account with the Stripe customer ID, set the package to be monthly subscription and status to be active. For those that purchase the lifetime package, their account will have package set to lifetime and status set to active. In this case, the Stripe customer ID will not be required. So that's the flow for when a user decides to purchase one of the two packages. The next flow will focus on monthly subscribed users that want to cancel or resume their membership. For that, they will first be faced with a cancel membership button, which once they click, it will make a call to our server, which will then call the Stripe API, telling it to cancel the subscription for that given user. Stripe will then cancel it and then fire a webhook event called Customer Subscription Updated that the server will listen to. Once our server receives the event, it will update the account for that user so that the status is set to cancelled. Now, the reason we have it set to cancelled and not inactive is because the user may still have the remaining month to continue using the application, given that they've already paid for it. What is cool is that once the remaining period is over, Stripe will then fire another event called Customer Subscription Deleted. Again, our server will be listening for this so that once it has been received, we can update the account to have the inactive status. There is also the case that a user may want to resume their subscription during the cancellation period. To deal with that, if their account has a status cancelled, they will be presented with a resume subscription button. This will work similarly to our cancellation process, just one step shorter. Once the button has been clicked, we will send a request to our server, which will then call the Stripe API with information regarding which user subscription needs to be resumed. Once Stripe has resumed that subscription, it will then fire a webhook called Customer Subscription Updated, which is the same one that we listen to when the user cancels. From there, we can set the user's account to have a status of active. So that's the architecture that we will be working with in order to get our authentication working with Clerk and customer purchases with Stripe. This entire eraser file will also be made available in the description below. Now let's go ahead and implement this. We will be making use of the T3 stack created by Theo. This will just make things easier to have our NextJS and tRPC all configured out of the box. To get started, make sure you're in your terminal within the right directory and enter npm create t3-at latest. Then give your project a title, select TypeScript, Tailwind CSS, tRPC, none for authentication provider, Prisma for the ORM, no for the NextJS app router, and then the database you want. I'll be going with SQLite. However, if you choose Postgres or MySQL, the implementation for this tutorial will be the same. Then you can choose if you want it to be a Git repo and then ask it to run the installations. If you want an import alias, you can choose one. I usually go for the @/alias. The next thing that we need are the other dependencies. Those will be Clerk, Stripe, Micro, and SVIX. We will also need one more installation, which will be Local Tunnel. This will be used for Clerk Webhooks during development. Once we're all set up, we need to create a Clerk account. For the purpose of this tutorial, we'll be using the free version, which in all honesty is enough to get you up and running for a real world product. So head over to clerk.com and sign up. Once that's done, you should be presented with a screen showing you your applications, if you have any. Click on New Application. Give your application a name and select which sign-in options you want to use. I'm just going to go ahead and use email and Google. However, there are many other options such as Apple, GitHub, or HubSpot. Once you click on Create Application, you should be presented with some environment variables it asks you to copy. So just copy them and head back to the code base and paste them in within the .env file. We will also be making use of Clerk's webhooks. Back in the browser, head over to the webhook section and click on Add Endpoint. Here it will ask you which endpoint will be listening to the events. The problem is that we cannot use our localhost server. However, we do have Local Tunnel, which we installed earlier. If we head over to the terminal and run lt port 3000, which is the port our Next.js app will be running on, we will get a unique but valid URL which we can use. If we stop running it and then try again, we will get back a different URL. During development, we don't want to have to keep changing the URL within Clerk. To combat this, we can add -- subdomain and then the name you want. I would recommend picking something that would be uncommon for others to pick. Once you have it, copy and paste it in Clerk and then add /API/webhooks/Clerk, as this is where our Clerk webhook listener will live. One thing to note is that when in production, this URL will be the one that hosts your application. For example, www.mysasapplication.com. Now for the events, we're just concerned with the one that states a user has been created. So check that and click Create. Once created, you can copy the signing secret Clerk credential and then add it into your .env file. The nice thing about the T3 stack is that it also comes with an env.js file where we can fetch our environment variables in a way that leverages the IDE and ensures that when we deploy, we have the right variables. Inside of it, I will add the Clerk secret key, which is a string, the Clerk webhook secret, which is also a string. Then for the client object, I will place in next public Clerk publishable key, which is also a string. Finally, in the runtime environment object, I will fetch the environment variables and associate them with the correct keys. So next public Clerk publishable key Clerk secret key, and Clerk webhook secret. Once that's done, in the _app tsx file, we'll import Clerk provider and then wrap the entire component within that. You also have to make sure that the page props are also passed in. Then we'll add a main tag that will be a wrapper for the component and set the class names to use mxauto, flex, a width of a half, flex direction column, and a padding of 5. We'll also be needing middleware, so for that, head to the browser, click on Home, and then Docs. For the NextJS docs, further down the screen, you will see information regarding middleware. We can copy the contents, and then within our src directory, we can create a middleware.ts file and paste them in. For the public routes, we can have /, which is the index page, and as for ignored routes, we can have / API webhooks, and then within brackets, dot and asterisk. For your use cases, you may need to change these. However, this is to ensure that Clerk remains happy for this tutorial. We also have API routes that can only be called if the user is authenticated. Therefore, we need to adjust the tRPC code so that it takes into account Clerk authentication. To do this, we can go into the tRPC file located in server API. Then from the Clerk Next.js server package, import getAuth and the types signed in auth object and signed out auth object. Underneath it, we can define an interface called auth context, where the auth will either be of the type signed in auth or signed out auth. Further down, we can have the create inner tRPC context, which needs to be adjusted so that it is async and accepts an auth context object. We can then include auth within the return object. For the create tRPC context function, we can include auth within the context object by calling the getAuth function and passing in the request. Then we can create a isAuth middleware that has the object values next and context. Within that, we can check if the user is authorized. If they are not, then we can throw an unauthorized error. Otherwise, we can return next and include the auth within the context. Finally, we can export our protected procedure, which will use the isAuth variable we just defined. We can use this now to define routes that only authorized users can call. We also need to create the model for our account. So inside of the schema.prisma file, get rid of the post model and then add a model account. And then within the curly brackets, we have the ID, which will auto increment, the user ID, which is a string. And remember, this will be the user ID that comes back with Clerk. Then created at and updated at, the Stripe customer ID, which is either null or a string, package, which is a nullable string. If you are using Postgres or SQL, you would typically use an enum for this. And then the status, which will have a default of inactive, because when the user account is first created, it will be inactive as no payments will have been made. This column will also be better as an enum if you're using something like Postgres as your database. We can then run npx prisma format to clean up the file, then prisma migrate dev to apply our changes onto the database, and finally prisma generate to ensure our ORM is up to date with the new changes. If we run npx prisma studio and head to the URL, we should see our account table without any data. We now need to start implementing an interface for our application. So head into index.tsx file and delete everything. We can start by exporting our home page and returning a section that has the class names margin top 10, flex column, and a gap of 8. Inside of it, a h1 tag with a title of your choosing that has the class names text center, font sans, text size of 5XL, font extra bold, and tracking tight. We then need to import the following from Clerk Next.js. Sign in button, sign up button, sign out button, and the use user hook. These buttons take care of the authentication for us, which makes our lives so much more easier. Then we can call the use user hook and extract the isSignedIn variable. Under the h1 tag, we can say that if the user is signed in, then the sign out button will be rendered. Inside of it, we can add a styled HTML button with the class names mxauto, width minimum, white space no wrap, border with a color of 900, background gradient to bottom right, from rows 500 to 700, a padding on the X of 10 and Y2, a text size of 2XL, tracking wide, text neutral 100, and a medium shadow. Then, if the user is not signed in, div with the class names mxauto, flex column, and a gap of 4. Inside of the div, we can copy and paste the sign out button and replace it with the sign up button, whilst also replacing the rose color with indigo. Underneath it, we can add the sign in button, which will be more subtle in appearance. This will have a URL redirect to the index and the classes text center, size of large, bold font, and a color of indigo 900. The last change we need is to remove the extension within the Tailwind config, and then within a terminal, we can run npm run dev. In the browser, we should see a sign up or login button. When you click on sign up, you can choose how you want to proceed. I'm going to go with Google, and once we're in, we end up back at the index page with a sign out button. That's all looking well and good. However, let's have a look at what is or is not happening behind the scenes. If you have the Prisma Studio running, the account table is still empty. This is because we're not actually receiving any of the webhook events that will trigger us to create one. Now, if we head over to the Clerk dashboard, you should see the user that has just signed up within the users list. But if you go to webhooks and click on the one that we are using, you should see the user created event within the logs. That is the one we need to listen to. Right now, they're all failing because there's nothing listening out for it. So let's go ahead and create our Clerk webhook listener. The first thing we need to do is create a directory inside of Pages API and call it webhooks. Then within that, create a TypeScript file called Clerk. Then we need to make the necessary imports. We need webhook from svix or Sphinx, which will help to verify the events, buffer from micro for passing the request body, env so we can access our webhook secret environment variable, and db so we can access our database. Then for the types, we can import webhook event from Clerk NextJS server and the next API request and response types. We then need to define the configs so that we disable the default body parser of NextJS. Then export default async function handler, which takes in a request and response. Within that, we check to make sure that if the request method is not a post method, then we will respond with a 405 error. Otherwise, we fetch the webhook secret from env, and if it doesn't exist, then we can throw an error. Then we need to access Sphinx ID from the headers, as well as the Sphinx timestamp and signature, and pass them as strings. We will need this to verify a request in a second. If any of them are missing, we can return a 400 error. Otherwise, we can pass the body using buffer from micro and convert that to a string. Then create a webhook object from Sphinx and pass in our webhook secret, and then create an empty webhook event variable. We can then create a try catch where we verify the request body using the Sphinx ID, timestamp, and signature as a webhook event. If it fails, then we know that the webhook was incorrect and then return a 400 error. Underneath that, we can extract the ID from event.data and also from the event type. Then we can create a switch that takes in the event type. Given that we are only listening for user created, we can add that as a case. Then we can check to see if the user ID already exists by using count and passing in the ID we got back from the event data. If the count is 0, then we can create an account by just passing the user ID, as that is all we need for creation. Then for the default case, we can console error that the event type is not configured. Finally, we can return a response status of 200 and pass in a message stating success. Now that we have that, head back to the Clerk dashboard and remove the user you created when testing it out earlier. Then in the terminal, make sure you have the NextJS application running on port 3000, and then in another session, run local tunnel with the same subdomain that you provided Clerk. When you go to the URL, you may need to enter a password. You can get that by checking out this link. Once you're through, go ahead and sign up again. Once that's done, you should be back at the home screen. However, this time when we check the database, we should see that an account has been created with a user ID that signed up. We'll also see in the Clerk logs how a user created event type succeeded. Looking back at the architecture, we can see how the implementation works, with the user clicking on the button and being sent to a Clerk sign up form. From there, the webhook event user created was fired that triggered an account to be created in our server. Great, now we have the user, but it's time to monetize that by implementing Stripe. Let's go ahead and do that now. The first thing that we're going to do is get our Stripe account all set up. If you head over to stripe.com, sign up and work through the process. This should only take you about 5 minutes. Once you're in the top right of the page, click on the test mode switch. We need this as we're working in development so that we don't actually test with real money or cards. In production, you'll do the same steps but just not in development mode. Then click on the developers button next to the switch, then on API keys. Click on the publishable API key to copy it and head back to the codebase. In the .env file, assign the value to the Stripe public key. Then go back to Stripe and copy the secret key and do the same thing, but this time to Stripe secret key. The next thing that you will need is the Stripe CLI. Unlike with Clerk, you can run the development Stripe webhooks on your computer. It also seems that you can do this online. However, I have not tried this feature. The installation guide can be found here. I'll add the link in the description. Once you have the Stripe CLI installed, you can start the webhooks by running stripe listen -- to localhost 3000 /API /webhooks /Stripe, as this is where our Stripe webhook will live, just like our Clerk one. When you hit enter, you will get the development webhook secret, which you can then copy and add it to your .env file. Then back in the Stripe browser application, we need to create the products that we're going to sell. For example, we have a monthly subscription and a lifetime package. Inside of product catalog, click on add product. The first one that we will create is going to be the subscription package. which I will call Rhythmic Subscription, and give it a short description. For the pricing, it's going to be a recurring one with an amount of $10 and the billing period to be monthly. Then we'll create another one which will be the lifetime package. I'll give this one a name of Rhythmic Lifetime and a short description, and set it to be one-off with a value of $150. Now that we have the products, we need the ID associated with them. If you click on the subscription package, you'll see the price ID, which you need to copy and paste into the .env file. I'm going to associate it with Stripe Subscription Price ID. We need to do the same for the lifetime package, so copy its price ID and paste it in the env file, this time with a name Stripe Lifetime Price ID. We're also going to need a URL which I'm going to set to localhost 3000. This will be used for redirects. Now, one thing to note is that all these values are for development. You'll have to create them again for production and not via the development tabs. This goes for both Clerk and Stripe. We then need to include them in the env.js file. You may think that this is an overkill, which I see that point, but for development and productivity, it can help in regards to type safety and validation. Be sure that you also have the spelling right and include them in the runtime environment object as well. Now that we have the environment variables all set up, let's create a page for the package selection. I'm going to create a new file within the pages directory called packages.tsx. In there, I'm going to define a component called packages page. This will return a section with the class names margin top 10, flex, flex column, and a gap of 8. Then a header with class name flex, width full, flex column, and a gap of 3. Within that, a h1 tag with the text select a plan. This will have the classes text center, a size of 4XL, font to be extra bold, and tracking tight. Underneath the h1 tag, we can add a sign out button from Clerk, which also automatically has been imported for me. Then a button with the text sign out and class names MX Auto, minimum width, white space no wrap, text center, and font bold. Underneath the header, we can create a container for the packages. Create a div with the class names flex and a gap 2.5. Then for the first package, we can have a div with the class names flex, height 40, a width of a half, flex column, justify between, border neutral 950, and background neutral 100. Then a h2 tag stating $10 a month with the class names text center, a text size of 2XL, font extra bold, and tracking tight. Underneath that, a subscribe button with classes border indigo 950, background indigo 700, padding on the Y of 3, text size XL, font extra bold, and a color of neutral 100. Then we can copy the package and paste it underneath, but within the div container. We can replace the title with lifetime for $150, change the button color to be sky, and replace subscribe with purchase. Now, assuming that you're signed in, back on localhost 3000, change the URL to be /packages, and you should see this. However, we can still go back to the index, which for this example we don't want. We want it so that if the user is inactive, they'll be redirected to the packages page. We can do this by adding get server-side props to the index page. So back in index.tsx, we can have export const get server-side props with the type imported from Next. This will be async and takes in context as a parameter. Inside of it, we can call getAuth from Clerk, pass in the request from context, and extract the user ID. We can then say that if the user ID exists, then fetch the account based on the user ID. We can then check to see if the status of the account is inactive. If it is, we will return an object with redirect that has a destination set to /packages. Then finally at the bottom, we can return an empty props object. Right now, TypeScript is complaining, so to shut it up, I'm just going to add a TS expect error comment above it. Now, if we head back to the home page and reload it, we get sent to the packages page. This is correct as the status is inactive for the account. Within the packages page, we can do something similar. We don't want customers to be able to access that page once they have an active account, so we can copy the server-side props from index page and paste it within packages. This time, however, we can replace the status to check if it is active. We also need a page for the user to be redirected to once they have successfully checked out. We could of course send them back to the index page, however it would be nice to let them know that their account is now active. Let's create a directory within pages called checkout, and then within that a file called success.tsx. We can start by defining the component, which is success page, and place in a section and a header tag within it, whilst also remembering to export it. We can then copy and get the server-side props from the index file, as we don't want inactive users to have access to this page. Then import the necessary packages, such as getAuth, db, and the type get server-side props. For the section, we can give it the class names margin top of 10, flex, flex column, and gap 8. For the header, flex, width full, flex column, and a gap of 3. Within the header, we can add a h1 tag that says, "Thanks for joining." That will have the classes text center, a text size of 4XL, font to be extra bold, and tracking set to tight. Underneath it, a div with the classes MX Auto, Flex, Width Full, Flex Row, and Justify Between. We can then add a Next.js link that sends us back to the index page with the classes Width Full, Text Center, and Font Bold. Then a sign up button with the class names Width Full, Text Center, and a bold font. Now it's time to create our tRPC routers. We can start by deleting the post example and then removing it from the root.ts file. Then inside of the routers directory, we can create a stripe.ts file. This is where our Stripe router is going to live. We can start by making the necessary imports. Z from Zod for type validation, the Stripe package, tRPC error for throwing errors, our env file, and then create tRPC router and protected procedure. Then to define our router, we can say export const Stripe router equals create tRPC router. For the first function, we are going to create get subscription checkout URL, which is a protected feature as we only want authorized users to access it. This will just be an asynchronous query that takes the context. Within the body of the function, we will first initialize Stripe, which will need the secret key from the environment variables and the API version. We will also need the URL, so we can store that too. For the checkout session, we need to await for stripe.checkout.sessions.create. And within that, pass an object where the mode is subscription. The line items is a list of objects where we have only one that will have a price set to the Stripe subscription price ID from the environment variables and quantity being 1. For the success URL, we can set that to the success page that we created earlier and add in the parameter session ID, which equals checkout session ID. For the cancel URL, we can just set that to the package's endpoint. Then for the subscription data, we can add metadata where we can throw in the Clerk user ID. This is important because when we listen for the webhooks, this will allow us to associate the Stripe account to the account we have in our database. Then we can run a check to see if we have a URL and throw a bad request error if it does not exist. Then finally, we can return an object with the property redirect URL set to the checkout session.url. We can then do the same thing for the lifetime subscription URL, where we initialize a Stripe object by passing in the secret key and an object outlining the version we want to use and get the URL. For the checkout session this time, we want to set the mode to be payment, as the lifetime package will just be a one-time payment. For the line items, the price we will use is going to be the lifetime price ID. The rest of the values will be the same as the subscription URL. I'm not sure why I didn't copy and paste it, but here we are. In reality, you would perhaps create helper functions rather than repeat code like we are doing here. However, I didn't want to keep jumping from file to file for the purposes of this tutorial. Once we have checked to see if the URL exists, we can just return the redirect URL with a checkout session URL. Inside of root.ts, we can then add our Stripe router so that it is now accessible within the application. Back inside of packages, we can then import API from util/API, and from Clerk Next.js, we can import useUser. Then within the packages page component, we can extract isLoaded from useUser and then call getSubscription checkout URL.useQuery and then pass in a void empty object as we have no arguments. Then in a separate object, set enable to isLoaded. That way we will only fetch the URL if the user is loaded. From this call, we can take out data and assign it to subscription session data. We can do the exact same thing for the lifetime checkout URL, also enabling it when the user is loaded and set the data to be lifetime session data. We can then create some helper functions, one being handle subscription checkout session, which will be async, and then for the redirect URL, we can set it to the one that comes back from the subscription session data. If the redirect URL exists, we can send the user to that address. We'll do the exact same thing for the lifetime one within handle go to lifetime checkout. Now that we have those in place, in the subscribe button, we can set the onClick to run the handle go to subscription checkout session. And then for the purchase lifetime, we can set it to the handle go to lifetime checkout session. If we head back to the browser, we can see that when we click on the subscribe button, we get sent to the checkout page for $10 a month. Whereas with purchase, we get sent to the $150 one-time payment. What happens when we actually subscribe to the $10 a month? Well, let's do that now. Stripe provides dummy cards that you can use to test. I usually go with 4 and then 15 ones and then add any random valid expiration date and CVV. When I click on subscribe, I get sent back to the packages page. If we head over to Stripe and click on subscriptions, you should see the customer that we just added via the Stripe form. Now you may be wondering why we land back onto the packages page and not on the success page as specified in the success URL. That's because we haven't changed the account status to be active, which is what is required for the success page. If we go to the Stripe CLI, we can see that a number of events were fired with a 500 error. That's because we currently do not have our Stripe webhook running on our server, just like we have with Clerk. The event that we are concerned with for subscriptions is customer subscription created. So now is probably a good time to start implementing our Stripe webhooks. To start with, create a file within Pages API webhooks called stripe.ts. And within that, make the necessary imports. They will be buffer from micro, the Stripe package, our env file and database, and then the types next API request and next API response from next. Once we have that, we can fetch a Stripe webhook secret. Remember, for now, this is the one provided by the Stripe CLI. In production, you will have to request one from Stripe web application. Then export the config similar to the one that we have in Clerk, where we have API and body parser set to false. Next, we have our async handler, which takes in a request and response as arguments. Within that, a try catch. First of all, we will call await buffer and pass in the request to pass the request body. Then fetch the Stripe signature from the request headers. After that, we can initialize a Stripe object using the Stripe secret key and a valid API version. We can then construct the event using Stripe webhooks construct event and pass in the request buffer as a string, the signature and the webhook secret. For the event types, we can use a switch statement, with the first one being the customer subscription created event. When we receive this event, we can take the subscription object from event.data.object, then update the user's account where the user ID is the same one as we get back from the metadata, and then status to be active, package to be monthly subscription, and the Stripe customer ID to be subscription.customer as a string. Then finally, a break statement. We then have the case for one-time purchases. As Stripe does not recognize them as subscriptions, we can listen for the event type checkout session completed. For this one, we can set payment to be event data object and then check to ensure that the payment mode is actually a payment. If it is, then we can update the user's account so that the status is active and the package is lifetime, and then finally break. For this case, we don't need a Stripe customer ID as those are only relevant to the subscriptions. At the bottom of the try block, we can respond with the status 200 and just say success is true. As for the catch, we can just have a console error and a response of status 500 and end. This time when we subscribe, we get sent to the success page, and you should also see that our account has been updated with monthly subscription active as well as a Stripe customer ID. You can also go ahead and try this out with the lifetime package. We can now head back to the home page. Great, so now users can be converted into paying customers. But what if we have users that have a monthly subscription and want to cancel it? We also have to make sure that if a customer cancels, they still get the period that they were billed for. The first thing the front end will need is information regarding the user's account. So inside of routers, let's create another route called account. In it, we can import create tRPC router and protected procedure from server API tRPC, and then export account router, which is assigned to create tRPC router. Within it, we will have one function called getAccount, which will be a protected procedure query that holds an asynchronous anonymous function. We can then extract the database and auth objects from it and return an account based on the user ID we get from the auth object. Then inside of the root.ts file, we can add the router and return to the index page where we can call the getAccount function, which has automatically been imported for me, and enable it so that it only runs if the user is signed in. The data we get back from it can be assigned to the account data and then wrap the sign out button with a div. The div will have the class names flex, flex column, and a gap of 5. Underneath, we can state that if the account data package is a monthly subscription and account data status is active, we'll render a button with the class names MX Auto, a minimum width, white space no wrap, and a bold font, and have the text to be cancel subscription. We can then copy this and paste another ternary operation underneath, but this time we check if the status is cancelled and change the button text to be resume subscription. The next thing we need are some functions to either cancel a membership or resume one. Inside of the Stripe tRPC file, we can create a procedure for cancel subscription, where we have an input that takes in an object that holds a Stripe customer ID and is an asynchronous mutation. We can take the Stripe customer ID from the input, initialize a new Stripe object with a secret key and API version. Then await for Stripe subscriptions list, where we pass in the Stripe customer ID. We can assume that each monthly active user has one subscription within Stripe, given the way this whole thing's set up. So we can get the Stripe subscription ID from subscription data with index0.id, and then call the Stripe subscriptions update API with our subscription ID and set cancel at period end to true. Finally, we can return a message stating that the membership has been cancelled. For the resume subscription, it will be very similar. We can copy the cancel subscription procedure, rename it to resume subscription, set the cancel at period end to be false, and the return message to be membership resumed. Inside of the index page, we can call our new functions. For cancel subscription, we can say api.stripe.cancel subscription use mutation. For the on success, we can have an anonymous async function that reloads the page. We need this as we will also have to wait for the webhook to come back to us. This just buys us time. We can then extract the mutate function and set it to cancel subscription mutation. Then underneath it, we can do the same for resume subscription, which again will have the same on success async function where we reload the page. Underneath them, we can create some helper functions. Handle cancel subscription, which will send the data off to our cancel subscription endpoint with the Stripe customer ID. We can copy this function and rename it to resume subscription, which will call our resume subscription mutation. Once we have those, we can attach the handle cancel subscription to the cancel subscription button and the handle resume subscription to the resume button. If we head back to the browser, we can see that we now have the cancel subscription button, which once clicked will reload the screen after the cancel subscription mutation has run. If we go to the Stripe dashboard, we should see that our subscription has been cancelled. For now, we can delete it. But back inside of our database, nothing has changed. As far as our app is concerned, the user's account is still active. This again can be solved with the power of webhooks. Let's set the Stripe customer ID and package to null and the status to inactive. Back in the app, if we reload, we should be sent back to the package page. Let's now implement the webhooks that will listen out for the cancel or resume changes. Back inside of the Stripe TS webhooks file, we can add a case for customer subscription updated, where we can grab the subscription and check to see if cancel at period end is true. If it is, we can update the account where the user ID is the one in the metadata and set the status to be cancelled. Otherwise, we can assume that the subscription has been resumed and set status to be active again. At the bottom of the case, be sure to add a break. If we head back to the browser and click on subscribe and fill in the checkout, and then head to the home page, we will see the cancel button. In our database, our account is active with all the other required information. Now, if we go back and click on cancel, we will see a reload happen and then a resume subscription button. Back in our database, the status has been set to cancelled. We can also see that in the Stripe dashboard, the subscription for that user will be cancelled on the 20th of March, so a month from now, giving the user time to still use the app. If we go back and resume the subscription, our database gets updated accordingly and the Stripe dashboard will show the subscription as being active again. However, what happens once March 20th has come by, or whatever cancellation date you have? Well, when this date comes by, Stripe will fire another webhook event called Customer Subscription Deleted. We can listen out for this so that when our server receives it, we can set the user's account to be inactive. So let's do that by adding a case for Customer Subscription Deleted. We can get the subscription from the event object and then update the account using db.account.update, where the user ID is the one from the metadata, and then set the status of the account to inactive, the package to null, and the Stripe customer ID to null also. Now head back to the Stripe dashboard where we can trigger it by clicking on the cancel subscription button. Once you've clicked it, head back to the app in the browser, and when you reload, we should be sent back to the packages page. The database will also be updated with inactive and null values, and in the CLI, we should see the event Customer Subscription Deleted was fired. Now, it's also very common for a subscription to have a trial. For example, you may want to offer a 7-day free trial. This is very easy to implement in Stripe. To do this, we can just add trial period days to the subscription data in the subscription checkout function and add the number of days. Now, when we go to the browser and check out, Stripe will tell us that we have 7 days for free. Once checked out, we can use the application the same as before. If we go to the Stripe dashboard, we can see that there's a trial associated with the user and they will be charged on that date. And finally, in the database, we have the same update information as before. And that, folks, brings us to the end of this tutorial. You can now implement user authentication with Clerk and monetize your application using Stripe in your NextJS tRPC application. If you enjoyed this video, be sure to like and subscribe and join the Discord server where you can share your journey and projects. Stay healthy, stay safe, and I hope to see you in the next video.